Welcome to the section 6.4. This is the lecture on section 6.4, trinomial squares and difference of squares. Wow, there's a lot there. In actuality, it's the same old stuff that we've been doing in the first three sections, so you're not really learning anything new. You still have to know how to factor. And by now you should know how to factor. It might not be immediate, it might not be as quick as you'd like to factor trinomials, but eventually you do more and more of these problems and factoring will be of second nature. But what is this business with trinomial squares and difference of squares? It turns out there's some special patterns that they want you to know. In the big world of trinomials, there are certain forms that, if you look at those at the original trinomial, you could spit out the answer for the factors immediately without doing much effort. So that's what they're talking about here, the special forms. Now, the first thing here is they're asking you in this first question, determine whether this is a perfect square trinomial, a difference of squares, or neither. Well, first off, I don't want you to really memorize the formulas that are in the textbook, in the slides that they provide for in my math lab. I want you to just factor this thing. Here, let's just factor this. So I just want you to do the same stuff that you know how to do already. So can we factor it? Let's see. I bet you we can. Okay. This is nothing special. It doesn't require magic squares or anything. Magic squares, magic numbers. X and X gives you the X squared. What else? Everything is positive. Everything is positive. And I want two numbers that multiply together to give you 64, add or subtract to be 16. Well, again, you need to know your times tables. You need to know how to add and subtract positive and negative numbers. So let's see, I think 8 times 8 would give you 64, and they would add to 16. So I think those would be the answers right there. And so this is something I don't think we've seen too much of so far. See, we have this factor and this factor look exactly the same. In fact, they are the same factor. So the way you would write that is you say you have x plus 8 bundle. You have an x plus 8 bundle squared. Okay, so that's the way you would write this top expression. So if I come up here and you say, well, how do I answer this question? Is it a perfect square trinomial? I'm going to tell you that the definition of a perfect square trinomial is this. You start off with a trinomial. And if you can factor it, and make it look like, and you get the same exact factors like we did here, and you could write it in this format with the square, that factor squared, then it is a perfect square trinomial. And so I'm going to go with this. I'll talk about difference of squares a little bit later. Check it out. That's it. Got that one done. And how about this one? Well, first off, there's three options: perfect square trinomial, difference of squares, or neither. First off, I don't think we can factor this. In fact, I know we can't factor it because we have a minus in front of the squared term. All our factors have been done. Factoring has been done with positive numbers in front of the square. So this is neither. If you can't factor it, forget about it. You can't do it. So let's see if that's right. Fine, that's good. And I'm going to let you do that one there. Now this guy here is a special pattern that I'm going to sneak right over here on the bottom. I'm going to say a squared minus 9, and you're going to say, whoa, where's the middle term? The middle term a. Well, it's there. The middle term a is there because I can make it look like this. A squared. Is there an a term, a regular a term? No. I can put down a 0. Why is it moving like this? It's always moving. 0a. See, 0a, 0 times a is 0. So it's as if I snuck in a 0 term in the middle there. Minus 9. And I can factor that. 0 is just a number like anything else. See, what I would do is I would ask the question, hey, a and a gives you a squared. I look at the number -9. How do I get a negative number? Well, one number's got to be positive and one number's got to be negative. And then I need two numbers that multiply together to give you 9. Add or subtract to be 0. See, 0 is just a number like anything else. I'm going to go with 3 and 3. See, this can be factored. This guy right here is the factor job for this expression here. First off, let me describe this expression. This expression here is a difference, that's a negative, difference means negative, of two things. The things that are involved in the difference have to be squares. Well, 9 is a square because there's a number 3 that multiplies by itself. Okay, I could write that to be 3 squared. That's what 9 is. That's a difference of squares. A is a square because A is being squared. So this is what's called a special pattern of difference of squares. And we're going to see that as soon as you see a difference of squares, I can go from here to here without having to go through all this mess that I showed you here. But all that mess, I won't have to do that. Am I right? I think so. I think I've done this enough to know it's right. So here, let's try something a little harder, a little bit harder than that. Okay, let's go back. Starting from number 5, 6, and 7, they're basically the same problems. Factor these things. Factor them. I'm going to go in the middle. And I'm going to say, can we factor this? I think we can factor that. Okay, I'm going to start off assuming we can factor it. 2 terms times 2 terms. I look at the r squared. Well, the only way we get the r is to get r and r. Now, everything is positive here, so there's no reason for any negativity. So I put a plus and a plus. And now what we want to do is ask the question, hey, give me 2 numbers that multiply together to give you 49. Add or subtract to be 14. And I'm going to go with 7 and 7. 7 and 7. Okay. And if I do a FOIL, certainly we'll get the 49, certainly we'll get the r squared, but the outer is 7r, the inner is 7r, add them up is 14r. There's your answer. I could check my answer and get it correct. It'll be correct. But what I'm going to do is do it the cool way, because we've got the same factors. We got r plus 7. I could write it as r plus 7 squared, and this is a trinomial square. Yay! Fantastic. So either doing it the old way, which is r plus 7 times r plus 7, or writing it the cool way. If you check your answer, it'll work. You'll get the green box. But I would prefer the cool way because you want to go into those math parties at UMass, and they demand that you do it the cool way. So let's come over here and say, well, factor this completely, huh? All right, let's copy this. Let's get rid of this. Get rid of this. Don't save it. Let's start with a fresh sheet of paper here. Okay. Put that right over there and say factor this completely. Now, first off, this is that special pattern I talked about. The special pattern is a minus. You have a minus here. Are the two things that are being subtracted, the difference, are they squares? Well, certainly x squared is a square because the variable x is being squared. But is there a number that exists that when multiplied by itself gives you 144? Yeah, 12. 12 times 12 is 144. Now, if you know about square roots, you'll get the answer on your calculator a lot quicker. So if I went in my calculator and put in 144, and this is the square root symbol here. A lot of times you don't see calculators having this 2. So this 2 here is optional. Just look at the square root symbol here, which is that radical weird symbol here. We're going to get into it much more detail in chapter 8. But assuming that maybe in high school you've seen square roots, if I click that and it comes out nice and even with no decimals, then That's the number that multiplies by itself that gives you 144. Now you're going to say, well, what's the big whoop about that? The big whoop is this. All I need to do is say, yeah, I can factor that without burning any calories. X and X is being factored. Then what I do is I put a plus and a minus. Well, certainly you have to have a plus and a minus because these two numbers over here have to multiply out to be a negative 144, and the only way to get a negative number is plus and a minus. And then you take that square root number, 12, and put that right. The thing that's being squared to get 144 is 12. And you're going to see this pattern a lot, and because you're going to see this pattern a lot, you're going to be able to factor it without much effort. Now, I know that's the answer. Okay, I know that's the answer. These are two separate factors, so don't go with any powers of 2s or anything. This is the answer. This is the only answer that works. If you do a FOIL, outer is negative 12x. Inner is 12x. So negative 12 minus 12 is 0x. There is no middle term. There's the answer right there. Nice work. Okay. Now, this guy right here, the one, you usually want to put the square in front. You remember I said you should always move your terms around and put the square in front. Unfortunately, there's always an exception to every rule, and this is one of the exceptions. When you see that this is a special pattern, don't move it around. Leave it the way it is. This is a difference of 2 squares. This is a difference of 2 squares because 49 is 7 times 7. 7 is being squared. W is being squared, and there's a subtraction in between. Don't move the number in front because if you were to move the number in front, you'll get a negative number. Okay, you would get a negative number that looks like this. And we cannot factor with the techniques I've showed you right now. You can't factor with a minus in front of the square term. So we're going to leave it alone. I'm going to say, well, leave it alone. This is the one time you just leave it alone. And you say, well, you ask yourself the question, 49, what's being squared to get 49? 7. 7. Because this follows the pattern of a difference of squares, you're going to say plus and minus. Okay, because you want a minus w squared. And the thing that's being squared to give you w squared is w and w. There you go. That's it. There's your answer. If I do a FOIL, you'll get 0w in the middle. There you go. So almost halfway done. I'm going to skip that. Now, I'm not going to skip that because you might think, okay, this looks like I might need a magic number technique. The thing that we did in section 6.3, the magic number technique. Now, when you do the magic number technique, what you need to do is pull off the 16, and then basically what you would do is pull off the 16 and do this, and try to factor an expression that looks like this, 24a plus. Now this number would be 9 times 16, which is 144. Now the problem with the magic number technique, and you could do this with magic numbers, the problem is you tend to generate a very big number here because you're multiplying numbers. And then it turns out to be a pain. You need a computer like my website to determine what two numbers multiply together to give you that big number and add or subtract to be the middle. Now, before I would go magic number, now when you do the magic number technique, you got to make sure that can you factor anything out of this? No, you got to leave it alone. So you have to leave it that way. Before you do magic number, what I would do is look at the first term and look at the last term. Are those perfect squares? Forget the middle guy. Are those perfect squares? If they are, then let's take a chance on something. Let's say we have 2 terms times 2 terms. What I would do is ask myself, what's the thing that's being squared to get 16a squared? Well, I would say 4a and 4a. Leave a little space to leave a sign. Leave a little space. Ask yourself, what's being squared to get the 9? Well, 3 and 3. Just attempt. It might not be right, but you got, magic number is in itself a technique that requires a lot of work, and I'd rather not do that work. If I can get the answer with a minimal amount of effort, that'll be good. Now, here's the deal. What about the signs? Well, they got to be double negatives because the double negatives would multiply out to be a positive 9 and negative in the middle. So let's try this. Minus and minus. Let's clean it up a little bit. Get rid of all those extra spaces in between. Now, is that going to be the answer? It is going to be the answer. Just do a FOIL. Okay, FOIL. See, certainly we'll have the 16a squared, the 9, but what about the middle term? The middle term is the combination of the outer 12a, negative 12a, and the inner, another negative 12a to give you negative 24a. That's your answer. I can click check answer and get it right. I will get it right, but I notice it's basically the same factor written twice, and I want to do it the cool way by saying it's 4a minus 3 squared. Okay, check your answer. There it is. That was a perfect square trinomial. All right. Now I'm going to skip that one. Okay. No, I want to skip that one. I'm going to. Okay, let's do this one. First off, I'm going to move these terms around. I'm going to move these terms around because I'm going to put the c squared in front, and if I put the c squared in front, I'm not going to have a negative number, so that's good. That's good. 9c squared. That's a good way. The minus 48. C would be still in the middle, and then the plus 64 would be at the end. And it looks like a magic number, and you certainly could do this with a magic number. But I want to try to avoid it because there's too much work in the magic number technique. I can't factor anything out. So what I'm going to do is I'm going to say, well, let's look at the first term. Let's look at the last term. Forget the middle. And ask yourself, what's being squared to get the first term? 3c. 3c, 3c. Okay, look at the last term. Is that a perfect square? Yeah, what's being squared? 8. 8 and 8. Now, what about the signs? Got to be double negatives. Got to be double negatives, because that gives you a positive 64 and negative in the middle. Now, you should check yourself to see if you do get negative 48, and I think you do. Outer plus the inner, negative 24c, and the outer is negative 24c. Add those together, you get this. There's your answer. Now, you could just enter this. You could just enter this. But I want to do it the cool way because I notice it's the same factor written twice. And if it's the same factor written twice, I would say 3c minus 8 and square it. Check your answer. Well done. Yeah, I love it. Love it. Okay. Now, what I'm going to do is just scan ahead and take a look and see what we got. Okay. Okay, this guy right here, I'm going to separate from what we did here. All right, I'm going to look at this. Is this a perfect square? Yes, it is. 49 is 7 and 7. This is 3v. So what I'm going to do is I don't even need any space to do this problem because I know the pattern for the difference of squares. Okay, get it ready with some parentheses. The thing that's being squared for the 9v squared is 3v and 3v. Difference of squares requires a plus and a minus in the end answer. The thing that's being squared to get 49 is 7 and 7. And that's it. You're done. That's it. That's the difference of squares. Check your answer. Nice work. Is this a difference of squares? A lot of people get this wrong. And I'm going to warn you, don't get this wrong because it's an easy question to get. You're going to see this kind of question on homework, on quizzes, on tests. This is not a difference of two squares. There's a plus sign here. In fact, there's no, okay, even if I expand it to look like this, 9x squared plus no x in the middle, plus 4. Okay, there's no two numbers, whether you come up, there's no way. Now remember, 0 in the middle is a 0 is a number like anything else. So the techniques that we use in the first 3 sections even apply to the 0 in the middle. I mean, there's nothing special about 0 there. But there's no number when multiply. There's no way to factor this. There's absolutely no way to factor it, because if I try to factor it, you got to generate this and this, and you got to generate the 4. It's 4 times 2. I can't say plus and minus, because a plus and a minus would give me a negative 4. I can't say 2 pluses. 2 pluses, okay, would generate 6x and another 6x, and that would be 12x. There's no way to factor that, no matter what you do. So when there's a plus in there, you can't do the problem. It's prime. You can't factor it. So that's something that you should be able to look at, get it, go on to the next problem, because that is not a difference of squares. That's a sum of squares, and you just can't do sum of squares. I'm going to skip that one. I'm going to do this one. Is this a difference of two squares? 2 squares means 2 terms, minus in between difference, and this thing here is a difference, and this guy here is a square. Okay, 6x is being squared. Okay, 7y is being squared. Now, the other term is a 6x minus 7y. It's a plus and a minus. When you have a difference of terms, you have to have a plus and a minus. And that just makes sense, because the last term has to be negative. Okay? Well done. Yeah, very good. Okay, let's factor this completely. This is a little. You might forget the simple stuff, so I don't want you to forget the simple stuff. Don't save it. Start over, fresh, new. Okay. Let's move this over here. Now, here's what I mean by the simple stuff. Don't forget that basically all you're doing in this section is factoring. The same rules that we learned before. And whenever you factor, you try to do the greatest common factor. Can we pull anything out? Yes, we can pull out a 4. You got to always pull out the greatest common factor. When you pull out a 4, you divide everything by 4. 4 into 32 is 8, and 4 goes into 64 16 times. And then you try to factor this. And at this point, you should be able to say two D's, 2 pluses, 4 and 4. Okay, so this is the same term. This is the same term, so I'm going to say D plus 4 squared. But let's not forget to put the 4 in front of it, because that's part of the factor job as well. So let's see if we get the correct answer here. I'm sure it is. D plus 4. Let's square it. Square it, square it. Check your answer. Well done. See? Don't forget all the techniques. This section is no different from any other section. It's just that we have some certain patterns that might help you in giving you the factor answer. We'll look at that. Let's take a look at this. Okay. What I'm going to do is say, well, I think I could sneak this in here. You still have to take this. Okay, and now let's see. I like the way it's written. Powers are going down. 3 squared, and that's implied 1. I can pull, you have to pull out the common factor. It also looks like I can divide everything by 3. So it looks like I can pull out a 3y from that expression. I have a minus and plus separating those terms. 3y. 3 goes into 3 once. I pull out 1y from 3, gives me the square. Okay? And then 3 goes into 30 10 times. Pulled out 1y. That was a square. I pulled out 1y, gives you that. And then plus 25. See, I pulled out the y, and then, see, I know that's the right answer when you multiply. You should too. Okay, when you multiply through, you should get the original problem. So you have to pull out the greatest common factor. You always have to do that. Then we focus on this pattern, squares, variables, numbers, and at this point, that's a simple one to do. You don't need anything fancy. Y and Y, double negatives for the positive 25, negative in the middle. And 5 times 5 is 25 and add up to 10. There's your answer. But I want to enter it the cool way. And the cool way is to say, geez, 3y is part of the answer. So write down 3y. The cool way is to recognize that that is a factor and that's the factor and they're the same factor. So you've got 2 of those factors. So I take y minus 5 bundle and square it. Check your answer, and there you go. And last but not least, let me see which one's the harder of these two. They're basically the same thing. Basically the same thing. So I'll do the last one. Close this, don't save it. File new. And let's see what we got here for this problem. 9x to the 4th minus 144 x squared. Can we pull out a 9? Let's see. Does 9 go into 144? Okay, I'd like to think that I could pull out a 9 from 144. So here's what I do. I use my calculator. Let's clear the calculator. 144. Could I divide it by 9 evenly? Yes, 16. It does go in even. I'm going to close it now. Because we know what that means. I can pull out a whole 9. And I can pull out an x, because there's x is common to both terms, and take the lowest exponent as the squared. And what's left over? What's left over is an x squared, because the 9 goes into 9 one time. I pull 2 x's from 4, leaves me with a square, minus 16. I pulled out the x squared, and this goes, I know that's the right answer. In terms, don't enter this, because that's not factored fully. I mean, it's factored, but it's not fully factored because this is a special pattern right over here. Squares minus 16, that's a difference of 2 squares, which I write like this. Okay, the thing that's being squared to get x squared is x. The thing that's being squared to get 16 is 4. I write that, but now when you enter the answer, make sure you enter it, put that 9x and x squared in front of it. So let's see if this is right. 9x squared. Make sure 9x squared. Bring it down. X plus 4, x minus 4. And check your answer, and I think this is done. We're done with this homework, and you should be able to bang that out and get her done. All right, so we'll see you in section 6.5. Good luck.